So for any of those of you that need help with adding and subtracting rational expressions, this is one of the major concepts of the unit. We're just going to go ahead and get started with some examples. So the first thing that you want to do is make sure that you're always focused in on what's in between here. So it says to add these two rational expressions. So the first thing, once you realize that you're adding, is that you want to look at the denominator of each one. Now, if your denominators are the same, like they are here, what you do, very simple, you add the top and keep the bottom the same. So that would be 4x squared plus 2x squared, which is 6x squared. 2x is the only like term for itself, so that's just 2x. And then 7 plus 12, which is 19. And you keep the bottom the same, just like with fractions. You add the tops, keep the bottom the same. And this would be your final answer. All right. The same exact thing is done for subtraction. So again, you want to really pay close attention to what's in between here. It says to subtract the two rational expressions. So again, we're going to look at the bottom of each. They are the same already, so go ahead and subtract the tops. So you have a 5, and I'm going to read this as a negative 3x squared. So that would give me 2x squared. I have 2x, and then this, because of subtraction, is really a positive 4x. So that gives me 6x. And then lastly, I have this negative 5. Alright, and that's all over 7x. And again, that's my final answer. Okay, so the steps, if you have the same denominators, go ahead and add and subtract the tops and keep the bottom the same. So here's another example, and again we're going to look in between. So here we have addition, and when I look at the bottom, I have x plus 1 over here, and over here I have x plus 2 and x plus 1. So they're not the same, but that can be fixed really easily. All you need to do is put what's missing over here on top and bottom. So I need an x plus 2 on top and bottom, and I'm going to put it there. Okay. Now what you have is you have the bottom parts so that they're the same. So now we're allowed to add the tops. That just means that you need to actually multiply right here. So that's 2x, and 2 times 2 is 4, okay, plus another 4 on top, and that's all over x plus 2 times x plus 1. Okay, these two things here are like terms, so 4 and 4 I'm just going to erase, and 4 plus 4 is actually 8. Okay, so our final answer, 2x plus 8, all over x plus 2 times x plus 1. Alright, and then for our final example, not to sound too repetitive, but again, start paying attention to whether you're adding, subtracting, multiplying, or dividing. We are adding these two expressions, and so you're going to want to make sure that your bottoms are the same. Now, these are not the same at all. So there's kind of like a shortcut, it's kind of quick. In order to make them the same, this would need to have x plus 2 here, so I'm going to put that on top and bottom. In order for this one now to match this one, I need to put an x minus 1 over here. Okay, so now our bottoms are the same. We're allowed to add the top parts. The only issue is, again, we have to multiply these out before we can add. So I need to multiply 3x times x and 3x times negative 1. That's 3x squared minus 3x. Then I have this plus. Okay, that's 5 times x, and 5 times 2 is 10. Okay, and that equals 3x squared plus 2x plus 10. And that's all over x minus 1 times x plus 2. Okay, and again, that's your final answer. And I know that's my final answer because, and I haven't been doing this, but you would try to factor the top at the last step if you can, but that doesn't factor. So you're finished. That's all there is to it. Watch the video again if you have any more questions, or you can seek some outside help.